Hey guys, my name's Anne-Katherine. I'm a second year grad student in the physics department here at UCI, and today I have a video for you all going over the week 4 practice quiz problem number 2. So you can find that on Canvas in the week 4 module. All right, let's get started. Okay, so as you can see, our problem is up on the left top corner, and some relevant equations for the problem are written on the top right corner. So the first part of the problem is asking us to take our position and calculate and plot acceleration. So we are going to do this using derivatives. So the derivative of position is velocity, and the derivative of velocity is acceleration. So right now, as you can see, I'm writing down the derivative of that position function that was given. So this is just a polynomial derivative. If you need some refresher, you can check out the lecture notes, but I'm going through it really slowly, step by step here, to show you hopefully super clearly how we found our velocity. All right, so our velocity is given by 26t minus 36t squared plus 10. And then next we are going to calculate our acceleration, and we're going to do that by taking the derivative of that velocity function that we just found. So again, this is just a polynomial. So for that first term, we have 26 times 1, which is the power of t, times t to the power 1 minus 1, because you subtract 1 off of that power, although that's just going to be t to the 0, and anything to the 0 power is 1. The next term is similar. We multiply by 2 because that t was squared. And then finally, the derivative of any constant is 0, so that's that 10. So we get our acceleration equals 26 minus 72t. And that's it. And as you can see, 26 minus 72t is just a line. So that's going to be pretty easy to plot. So we've already done the first part of part A, which is calculate the acceleration. That's the acceleration. And now we're going to plot that line. And the easiest way to do that is just to find a couple points. So I'm going to find the acceleration at t equals 0, 1, and 2. So a of 0 just equals 26. A of 1 equals 26 minus 72 times 1, which equals minus 46. And I messed up drawing my 4 there, but I promise that is supposed to be a 4. And finally, a of 2 equals 26 minus 72 times 2, which equals minus 118. Okay, so we could have done this just using 2 points, because you just need 2 points to draw a line, but I just did 3 to help me draw my line a little bit more accurately. All right, so I am creating my t and a of t axes here. And we're just going to plot those 3 points and draw a line through them. So as you can see, I'm marking out where y, or a of t equals minus 118 is, where a of t equals minus 46 is, and where a of t equals 26. And then I'm looking at t positions of 0, 1, and 2. Okay, so hopefully this is straightforward to follow. I'm just going to plot the point 0, 26. 1 minus 46, and 2, comma, minus 118. And then I'm going to draw a line through those, and then we are done with part A of the problem. We found our acceleration using 2 derivatives, and we plotted it. Awesome. So moving on to part B. So as you can see on the right side, I drew out step by step how to find maximum and minimum values of x of t. So I'm just going to go through those really slowly and carefully. So number 1, calculate x prime of t. So we already did that in part A. X prime of t equals v of t, which I rewrote above. And again, that's equal to 26t minus 36t squared plus 10. And I am just in part 2, where we're setting x prime of t equal to 0, I just rewrote that. I switched the positions of minus 36t squared and minus 26t because that's how we're used to seeing polynomials. All right, and then step 3 is solve for t. So we are going to use the quadratic equation, everyone's favorite equation. And I'm going to go through this algebra pretty slowly so that it's hopefully really easy to follow. So if you're really good at algebra and you can just plug this into your calculator in one step, that's awesome. Just skip ahead a couple minutes here, maybe like 3 minutes or so. But for now, I'm just going to go through this algebra really slowly and carefully so that everybody can follow. All right, so that's our quadratic formula. Just a reminder, in that x prime of t equation, a equals minus 36, b equals 26, and c equals 10. So you can see I'm starting to plug in my numbers. I have to admit, I am a grad student and I did Google quadratic formula before I made this video. So if you don't remember it off the top of your head, no sweat, because I didn't either. Something that's really easy to do with this kind of formula is to forget our negative signs, like on that A. So make sure you keep your A negative. That's minus 36. And as you can see, my video editing got a little wonky here. I actually forgot to record at one point. So the formatting just changed a tiny bit, but the information is exactly the same. So don't worry about that little skip that just happened. All right, so inside that square root, I just squared 26, which is 676, and I did minus 4 times minus 36 times minus 10, which is minus 1,440. And then in the denominator, I have 2 times minus 36, which is minus 72. And I'm just slowly working out this whole little equation here. All right, so we have minus 26 plus or minus the square root of 2,000 something. I forget what it is. I'm about to write it in a sec. This little pause is probably me typing that into my calculator. There we go. 2,116 divided by minus 72. Again, don't forget your negative sign in the denominator. And then this is equal to minus 26 plus or minus the square root of minus 2,116, which, lucky for us, is a square root that we can do pretty easily. That's just 46. And then right now I'm writing down the plus version, and then I'm going to write down the minus version in a sec. So minus 26 plus 46 is 20 divided by 72, minus 72, excuse me. And that's equal to minus 5 divided by 18. And then the minus version, aka minus 26 minus 46, equals minus 72 over minus 72, which is a nice easy fraction, equal to 1. All right, so those are my two t values, minus 5 over 18 and 1. And if you look at the problem, it says find the greatest exponent for t greater than 0. So we're really only interested in that t equals 1, but t equals minus 5 over 18 is also a valid solution. All right, so just rewriting that so I have a little bit more room here. So we solved for t, that was our step 3. And then we're about to be on to our last step, plug this t into x of t, and I'm only going to plug in t equals 1 because, again, we're only interested in positive t values. So we're looking for our greatest x position for positive t. So x of 1 equals 13 times 1 squared. Again, going through this algebra pretty slowly. 12 times 1 cubed plus 10 times 1 plus 1. And, of course, that's equal to 13 minus 12 plus 10. That plus sign got a little messed up, but it is supposed to be a plus, I promise. Plus 1. And that is just equal to 12. So our greatest x position is 12. And we are done. So hopefully this was helpful. Thanks for watching.